My next class?
No, like your next test.
Oh, after this?
Yeah.
Depends on your major, I guess.
For some students, it's college algebra. Yeah, you can, you know how to check the catalog?
Yeah.
Yeah, that will tell you your math requirements. We'll start in 1 minute. Today we'll be in the second part of section 6.3 on factoring special products. So a reminder, factoring is the reverse process of multiplying, and you can check your factoring by multiplying. The first step in factoring is to factor out the greatest common factor of all of the terms. Okay, the next special product is called a sum of cubes. The sum of cubes has the following form: a to the third plus b to the third. So the term cube, you're probably familiar with that. If you cube something, you raise it to the third power. So a sum of cubes means you're adding two things that are raised to the third power. A sum of cubes has a binomial factor and a trinomial factor. So if you have something of the form a to the third plus b to the third, the binomial factor is a plus b, and the trinomial factor is a to the second minus ab plus b to the second. So we can verify this by multiplying. So we'll do that here. We'll multiply the binomial a plus b times the trinomial a to the second minus ab plus b to the second. Okay, so multiply a times every term in the trinomial. A times a is a to the third, and then minus a times ab is minus a to the second times b, and then plus a times b to the second. And then we switch over to the term b. Now we multiply b times every term in the trinomial. B times a to the second, we can write that as plus a to the second b, and then minus b times ab, that's minus a times b to the second. And then lastly, b times b to the second is plus b to the third. We combine like terms. Notice the minus a squared b and the plus a squared b, those add up to 0. And the plus ab to the second and the minus ab to the second, those add up to 0. So when we combine like terms, we're just left with the sum of cubes, a to the third plus b to the third. Okay, another special product is a difference of cubes. A difference of cubes has the following form: a to the third minus b to the third. So once again, the word difference refers to the fact that we're subtracting. And one of the quantities that we're subtracting is b to the third, or b cubed, and we're subtracting it from a cubed. Difference of cubes has a binomial factor and a trinomial factor. So when factoring something of the form a to the third minus b to the third, the binomial factor is a minus b, and the trinomial factor is a to the second plus ab plus b to the second. Okay, we'll verify this by multiplying. So first we multiply a times every term in the trinomial. A times a to the second is a to the third, and then plus a times ab is plus a to the second b, and then plus a times b to the second is plus a times b to the second. And then we multiply negative b times every term in the trinomial. So negative b times a to the second, that is minus a to the second b. And then minus b times ab is minus a times b to the second. And finally, negative b times b to the second, so we write minus b to the third. And some like terms cancel out. The plus a squared b minus a squared b, those add up to 0. And the plus ab to the second minus ab to the second, those add up to 0, and we're just left with a to the third minus b to the third. Okay, we'll do some examples where we factor sums of cubes and differences of cubes. Okay, here's our first example. Notice the greatest common factor of both of those terms is 1. And notice that 27 is a perfect cube because 3 to the third is 27, and m to the third is a perfect cube. So the entire term, 27m to the third, is a perfect cube. You can rewrite that as the term 3m to the third. And 64 is a perfect cube because 4 to the third is 64, and n to the third is a perfect cube. So 64n to the third can be written as the term 4n to the third. And then we just apply the sum of cubes factoring formula. So the binomial factor is 3m plus 4n. And then in the trinomial, the first term is the term 3m to the second. Sorry, 3m to the second. And then we're going to subtract 3m times 4m. And then we're going to add the term 4n squared. And we'll simplify a little bit more. The binomial stays the same, 3m plus 4n. And then in the trinomial, when we square the term 3m, we get 9m to the second. And then we subtract 3m times 4. This should be a 4n. So minus 3m times 4n is minus 12mn. And then finally, when we square 4n, we get 16n to the second. Okay, so just to reiterate what we did here, we had a sum of cubes, something of the form a to the third plus b to the third. And then the binomial factor has the form a plus b. The trinomial has the form a to the second minus ab plus b to the second. Okay, over here on the right, we have a difference of cubes. So 8 is a perfect cube. The term 8x to the third, we can write that as the term 2x to the third, and then minus y to the third. And then use the difference of cubes factoring formula. So the binomial is 2x minus y. And then the trinomial, the term 2x is raised to the second power. And then we're adding 2x times y. And then we're adding y to the second. And we'll simplify a little bit more in the trinomial. The first term is 4x to the second. That's what we get when we square the term 2x. And the middle term is plus 2xy. And then the third term is y to the second. Okay, so for this one, we had a difference of cubes, something of the form a to the third minus b to the third. The binomial has the form a minus b. And the trinomial has the form a to the second plus ab plus b to the second. Okay, the next example, 343n plus 125nt to the third. The greatest common factor of both terms is n. So we have to factor n out first. So we have n times 343 plus 125 t to the third. Inside the parentheses, we have a sum of cubes. So we're going to factor that. You can think of 343 as 7 to the third, and then 125 t to the third. That's the term 5t to the third. Okay, so the complete factorization has a factor of n. So we'll put the factor of n out front and then apply the sum of cubes factoring formula to 7 to the third plus the term 5t to the third. The binomial is 7 plus 5t. And then the trinomial, first term in the trinomial is 7 to the second. And then we subtract 7 times 5t. And then we add the square of the term 5t. Okay, we'll simplify a little bit more in the last step. So the complete factorization is n times the binomial 7 plus 5t. And then the trinomial is 49 minus 35t plus 25t squared. Okay, let's proceed to the next example. Now we want to factor 135b to the third y plus 320a to the third y. So first, factor out the greatest common factor. So take about 15 or 20 seconds and find the greatest common factor of both of the terms. Hey, what did you get for the greatest common factor? When we look at the numerical factors, 135 and 320, well, we know that 5 is a factor of both. So 135 is 5 times 27. 320 is 5 times 64. The other three prime factors for 27 are 3 times 3 times 3, and the prime factors of 64 are 6 factors of 2. So the greatest common factor of 135 and 320 is 5. Okay, but in these two terms, there's another common factor of y. So the greatest common factor is 5y. We factor 5y out of both terms, and we're left with 27b to the third plus 64a to the third. And inside the parentheses, we have a sum of cubes because both 27 and 64 are perfect cubes. So in the next step, we'll write the term 3b to the third. This is equivalent to 27b to the third. Then the other term, 64a to the third, that's equivalent to the term 4a to the third. Okay, so the complete factorization has this factor of 5y. And then we'll apply the sum of cubes factoring formula to the sum of cubes. So the binomial is going to be 3b plus 4a. And then in the trinomial, the first term will be what we get when we square 3b. Then we're going to subtract 3b times 4a. And then we're going to add the term 4a to the second. And then the last step, 5y times the binomial 3b plus 4a. And then the term 3b squared is 9b to the second. And minus 3b times 4a is minus 12ba. And then plus 16a to the second. Okay, so that is the complete factorization. All right, the next one, 125w to the third x minus 729b to the third x. Well, the greatest common factor of the two terms here is just x. So we begin by factoring out the greatest common factor x. And x times the quantity 125w to the third minus 729v to the third. Okay, well, inside the parentheses, we have a difference of cubes. Okay, I'll let you answer a question. What term do we raise to the third power to get 125w to the third? And then what term do we raise to the third power to get 729 to the times v to the third? So what should I put in this set of parentheses? Something raised to the third power equals 125w to the third. And then in the other set of parentheses, something raised to the third power equals 729v to the third. So what term do I raise to the third power to get 125w to the third.
5W.
Yep, 5w. If we raise the term 5w to the third, 5w times 5w times 5w, we get 125w to the third. Okay, what about the other one? What do we raise to the third power to get 729v to the third? Okay, we have an answer on YouTube. 9v 9v times 9v times 9v is 729v to the third. Okay, so now we can apply the difference of cubes factoring formula. Remember, we have a factor of x that tags along. Okay, so the binomial is 5w minus 9v. And then in the trinomial, the first term is what we get when we raise the term 5w to the second. And then we're going to add 5w times 9v. And then we're going to add what we get when we raise the term 9v to the second. And now we just do the arithmetic. So the complete factorization is x times the binomial 5w minus 9v. And inside the trinomial, when we square 5w, we get 25w to the second. And then we add 5w times 9v to get plus 45wv. And then finally, when we square the term 9v, we get 81v to the second. Okay, let's move on to the next page. Okay, this one, 216t to the third minus 27r to the third. This is well, it's a difference of cubes, but what's the greatest common factor? Well, the greatest common factor is bigger than 1. So remember how to find the prime factorization of a positive integer? So 216. Well, let's do a factoring tree. So this is 2 times 108. Bring down the 2. 108 is 2 times 54. And 2 times 2, 54 is 2 times 27. Uh, 27 is 3 times 9. And so the complete factorization is 2 times 2 times 2 times 3 times 3 times 3. And then 27, this is 3 times 9, or 3 times 3 times 3. So the greatest common factor of 216 and 27? 27, yeah. 3 factors of 3. So the greatest common factor is 27. So we factor 27 out, and we could use the prime factorization to help us know what we need to multiply by 27 to get 216. So 27 times 2 times 2 times 2 is 8. And inside the parentheses, we have a difference of cubes. So we can rewrite 8t to the third as the term 2t to the third. And then we'll apply the difference of cubes factoring formula for the difference of cubes. But we have a factor of 27. The binomial is 2t minus r. In the trinomial, the first term, we square the term 2t. Then we're going to add 2t times r. And then we're going to add r to the second. And then the last step, 27 times 2t minus r. When we square the term 2t, we get 4t to the second. And then plus 2tr plus r to the second. Okay, let's look at the next example. 250 x, y, u to the third, v to the third, plus 686 x to the fourth, y to the fourth. Okay, what's the greatest common factor of those two terms? Well, 250 is 2 times 125. And remember, 125 is 5 to the third. And then 686 is 2 times 343. And you might remember that 343 is 7 to the third. So the greatest common factor will have a factor of 2 in it. What else does it have?
X and Y.
Yeah, it has 1 factor of x and 1 factor of y also. So the greatest common factor is 2xy. So we first factor 2xy out. And then we're left with 125 u to the third, v to the third, plus 343 x to the fourth, sorry, x to the third, y to the third, because we factored 1 factor of x and 1 factor of y out. So inside the parentheses, we have a sum of cubes. So I'll replace 125 u to the third, v to the third with the term 5uv all to the third. And I'll replace 343x to the third y to the third with the term 7xy to the third. And then when we factor this, we have a factor of 2xy. And then apply the sum of cubes factoring formula. So the binomial is 5uv plus 7xy. And in the trinomial, we're going to square the term 5uv. We'll subtract 5uv times 7xy. And then we're going to add the term 7xy squared. All right, so the last step, 2xy times 5uv plus 7xy. When we square the term 5uv, we get 25u to the second, v to the second. And when we subtract 5uv times 7xy, we subtract 35uvxy. And then we're adding the term we get when we square 7xy, which is 49x squared y squared. Okay, the next example, x to the sixth minus x to the sixth minus 64. So what are we looking at? What kind of polynomial is that? Well, it involves subtraction, so maybe it's a difference of something. Well, this could be written as a difference of squares, because each one of those is something squared. So x to the third to the second is the same as x to the sixth. And 64 is 8 to the second. So we could think of that as a difference of squares. But we can also think of it as a difference of cubes. Because if you raise the term x to the second to the third, you get x to the sixth. And 64 is 4 to the third. So we can get the complete factorization starting out in either way. Okay, let's start out with the difference of squares. So just a reminder, a difference of squares, if you have a to the second minus b to the second, one of the factors is a minus b, and the other factor is a plus b. So on this one, a difference of squares, we have x to the third minus 8 times x to the third plus 8. Okay, but notice x to the third minus 8. What is that? X to the third minus 8 is a difference of cubes, because 2 to the third is 8, And then the other one, x to the third plus 8, is a sum of cubes. So we can factor each of those. So I'll rewrite x to the third minus 8 as x to the third minus 2 to the third. And then x to the third plus 8 is x to the third plus 2 to the third. So we'll factor each of those, and the complete factorization will be the factorization of those multiplied together. So when we factor x to the third minus 2 to the third, we get x minus 2 times x squared plus 2x plus 4. And then when we factor x to the third plus 2 to the third, we get x plus 2 times x squared minus 2x plus 4. Okay, so this is our factorization. Okay, over here, if we factor it as a sum of, or as a difference of cubes, so something cubed minus something else cubed, we have a x to the second minus 4. And then we have x to the fourth plus 4x to the second plus 16. And then x to the second minus 4 is a difference of squares. So that is x minus 2 times x plus 2. And what might not be apparent is that x to the fourth plus 4x to the second plus 16. So it's not immediately apparent that if we were to try to factor x to the fourth plus 4x squared plus 16, it would amount to multiplying x squared plus 2x plus 4 and x squared minus 2x plus 4. Okay, but this is just an example to show you that something can be two things at once. In this case, it is a difference of squares, but it's also a difference of cubes. Okay, let's look at the next page. So factor the following polynomials. So 4a to the second plus 28a plus 49. We can use the AC method. Or you might suspect that it's a perfect square trinomial because the term on the left, 4a to the second, is a perfect square and 49 is a perfect square. But let's practice the AC method. When factoring a trinomial in one variable, the AC method will always, if you apply it correctly, will always lead you to the correct result. So the AC method, 4 times 49 is 196. And we want to find two integers that have a product of 196 and a sum of 28. If the product is positive and the sum is positive, then they both must be positive. So if we start at the extremes using our systematic approach, 1 times 196, those add up to 197. Then 2 times 98. 3 is not a factor. 4 times 49, we already knew that one. 5 is not a factor. 6 is not a factor. 7 is a factor. 7 times 28. Those add up to 35. So we're getting closer. 8 is not a factor. 9 is not a factor. 10 is not a factor. 11 is not. 12 is not. 13 is not. 14. 14 times 14 is 196. And 14 plus 14 is 28. So we can factor it. Since the two integers we're looking for are the same, that remember what that means. That means this is a perfect square trinomial. So we'll proceed with the AC method. Transform the trinomial into a quadrinomial. So replace the plus 28a with plus 14a plus 14a. And then factor by grouping. Out of the first two terms, we factor out 2 times a. And the binomial that stays behind is 2a plus 7. The middle operator is addition, so we bring down addition. And then group the third and fourth terms. The greatest common factor of 14a and 49 is 7. And factor that out, we get 7 times the binomial 2a plus 7. And then the complete factorization, 2a plus 7 times 2a plus 7. So here's another proof that the original trinomial is a perfect square trinomial because the two factors are the same. Okay, on the next one, 36b to the second minus 60b plus 25. The greatest common factor of all three terms is 1. Maybe it's a perfect square trinomial because 36b to the second is a perfect square and 25 is a perfect square. So let's try this. If it is a perfect square trinomial, what should the factors be? If it is a perfect square trinomial, then the factorization is what? Well, in the trinomial, we have minus plus, so the binomials have to both be minus, have minus signs. The term on the left of each of the two binomials is the square root of 36b to the second. If it's a perfect square trinomial, this term should be 6b, and this term should be 6b because 6b times 6b is 36b to the second. And what should the term on the right of each of those binomials be? 5, yeah. So 6b minus 5 times 6b minus 5. So this is the factorization if it's a perfect square trinomial. We could verify by multiplying the two binomials. 6b times 6b is 36b to the second. And then minus 6b times 5 is minus 30b. And then minus 5 times 6b is minus 30b. And then negative 5 times negative 5 is positive 25. And sure enough, we end up with the trinomial that we're starting out with. So that means we now know the factorization. So that is a perfect square trinomial, and its two factors are 6b minus 5 times 6b minus 5. Okay, the next example, factor 25xw to the second plus 100x. The greatest common factor is different than 1. 25 is a common factor, and so is x. So when we factor 25x out, we're left with w to the second plus 4. W to the second plus 4 is a sum of squares. So this is the complete factorization. But the original polynomial is factorable up to this point. So since we were able to factor it this much, it would be incorrect to say non-factorable because we factored it this much. So this is the factorization. Okay, the next one, 81c to the second plus 54c plus 9. What is the greatest common factor? How much?
3.
There's a bigger one, a bigger factor than 3 that's common.
9.
Yeah, 9. So factor 9 out, and we get 9 times the quantity 9c squared plus 6c plus 1. And we're out of time. So we'll stop there and go ahead and sign in for attendance.
When's the next exam?
Next test?
Yes.
A week from tomorrow. I'll send out information this week about it.
Okay.